Hello, good day. Today I'll be discussing lecture 4.4 of Math 21. I have divided this lecture into 3 videos. The first part will discuss the properties of the definite integral, and the second and third parts are the first and second fundamental theorems of calculus, respectively. Okay, so let's go to the first topic. Recall that in a previous lecture, we have already defined the definite integral of f of x from a to b. It is given by this expression. Okay? And it's defined to be the limit of the summation of f of xi star delta x sub I from 1 to n as n approaches infinity if this limit exists. And if this is true, we say that the function f is integrable on the closed interval ab. First, let's look at the relation between continuity and integrability. But first, let's recall what's the relation between continuity and differentiability from our previous lectures. A, if a function is continuous, then it is differentiable. Or B, if a function is differentiable, then it is continuous. What do you think is, or what do you recall is the correct answer? The correct answer is B. If a function is differentiable, then it is continuous. Now we look at integrability and continuity. The theorem says that if a function is continuous on a closed interval ab, then it is integrable on that closed interval. So continuity implies integrability. Okay, so what functions do we know or which we have discussed na continuous? First, yung polynomial functions. We know that polynomial functions are continuous everywhere. Therefore, by this theorem, we say that polynomial functions are integrable on any closed interval. The absolute value function is also continuous. Therefore, we say that absolute value of x is integrable on the closed interval negative 1 to 2. But remember, diba, yung absolute value of x is not differentiable on the open interval negative 1 to 2 kasi meron kayong corner at x equals 0. Okay? Next, the sine and cosine functions. Alam natin na continuous sila everywhere, therefore, they are integrable on any closed interval. Okay. Here are some properties of the definite integral. First, the definite integral is a number which does not depend on the variable used. So you can use f of x dx or f of t dt. Their integral from a to b are equal. Okay. Next, if the function f is continuous, a regular partition can be used to compute the definite integral. Last, to define the definite integral, ab, or the closed interval ab, must be a subset of the domain of f. If you look at this example, the integral from 0 to 1 of 1 over x squared is not a definite integral. Why is it not a definite integral? What's the domain of the function 1 over x squared? All real numbers except 0. Okay? Yung 0, 1 is not a subset of the domain of f. Therefore, this is not a definite integral. Ano ngayon yan? Okay? Itong integral na to, which we call an improper integral, will not be discussed in Math 21. Okay? This will be discussed in Math 22. Okay? So now let's look at some of the properties of the definite integral. Okay, so let f and g be integrable on the closed interval ab, and c, p, q, and r are real numbers. Okay? First property, the integral from a to a, okay, so pag pareho yung limits of integration, integral of f of x dx from a to a, the integral is equal to 0. Okay? Next, in this case, ni-reverse natin yung limits of integration. Okay, so when you reverse the limits of integration, the integral from b to a of f of x dx is equal to the negative of the integral from a to b of f of x dx. Okay. Next property, yan. If you have a sum or a difference, you can get the definite integral of each of the terms. Okay. So yung integral from a to b of f of x plus or minus g of x dx is equal to the integral from a to b of f of x plus or minus the integral from a to b of g of x dx. Okay, sige, unahin natin itong nasa taas. The integral from a to b of a constant c times dx is equal to c times b minus a. Remember, yung definite integral is area. Nakuha natin yung area, di ba? So, if you have y or f of x equals c, suppose ito yung graph ng function natin. It's just a horizontal line because we have a constant function. And you have the interval from a to b. Diba? You'll form a rectangle. Tapos, ang area ng rectangle is just length times width. So, c times b minus a. Okay? Next property. The definite integral of c f of x dx from a to b is equal to, pwede nyo ilabas yung c. C times the integral of f of x dx from a to b. Okay, and then last property. Okay, so suppose the closed interval AB contains the real numbers p, q, and r. Then, the integral from p to q, so take note of the limits of integration. The integral from p to q of f of x dx is equal to the integral from p to r f of x dx plus the integral from r to q f of x dx. So, parang kinat natin sa r. Okay? So, this property holds regardless of the order of p, q, and r. Okay? So, let's look at some applications or examples of these properties. First, we want to find the integral from 0 to 1 of f of x dx, given that the integral from 0 to 2 of f of x dx equals 2, and the integral from 1 to 2 of f of x dx equals 3. Okay, so we want to find, ito yung goal natin. Okay, we want to find the integral from 0 to 1 of f of x dx. Pero ang alam natin, sige, highlight natin yung mga limits of integration. Okay? Sige, yung isa, 0 to 1, 0 to 2, and then integral from 1 to 2. From the property, actually from the last property that we have discussed, what can we say? Yung integral from 0 to 2 of f of x dx can be written as the integral from 0 to 1 of f of x dx plus the integral from 1 to 2 of f of x dx. Okay, and we want to find the value of this expression or this definite integral. So, we isolate it on one side. So, kung nandito yung integral from 0 to 1 of f of x dx, this is equal to the integral from 0 to 2 of f of x dx minus the integral, tama? Transpose nyo sa kabilang side yung integral from 1 to 2 of f of x dx. Okay? So, we have this expression. Just substitute the given values. Integral ng f of x dx from 0 to 2 is 2. Minus, integral from 1 to 2 of f of x dx is 3. Okay, so 2 minus 3, this is equal to negative 1. Okay? Madali lang. Okay, so next example. Given that the integral from negative 2 to 5 of f of x dx is 4, and the integral from negative 2 to 5 of 3g of x dx is negative 9, we want to evaluate the integral from 5 to negative 2 of 3 f of x plus g of x dx. So, tingnan natin dun sa mga given. Okay, take note. Okay, baliktad yung limits of integration. Again, we use the property na pag ni-reverse natin yung limits of integration, i-negate nyo lang yung definite integral, yung value ng definite integral. So, let's do that. So, yung integral from 5 to negative 2 of f of x dx should be equal to yung negative ng value na to, which is negative 4. Okay? Dito naman, sa g of x, merong kasamang 3. Pero dito sa gusto nating hanapin, wala nang coefficient na 3 yung g of x. So, we isolate yung integral of g of x dx. Okay? So, if you have 3 integral from negative 2 to 5 of g of x dx, this is equal to negative 9. So, if you divide both sides by 3, okay, the integral from negative 2 to 5 of g of x dx is equal to negative 3. And then, gusto natin integral from 5 to negative 2 of g of x dx. So again, we negate negative 3. This is equal to positive 3. Okay, so are we ready now to substitute to this expression? Okay, so the integral from 5 to negative 2, sige, pwede nating ilabas na yung 3. Then, paghiwalayin natin yung f of x and g of x. So, this is equal to 3. Integral from 5 to negative 2 of f of x dx plus integral from 5 to negative 2 of g of x dx. Okay, then we just substitute the values that we obtained. Integral from 5 to negative 2 of f of x dx is negative 4. Integral from 5 to negative 2 of g of x dx is 3. Okay, so we have 3 times negative 4 plus 3. This is equal to negative 9. Okay? So before you watch the discussion videos, please try to answer these items. Okay? So it's in page 219 of your module, part C, practice or answer items 1 and 5.